Hello everybody, I am Peiman Pilechiha. I have a PhD in High Performance Architecture. Today I am going to briefly present a research titled Energy and Daylight Performance Optimization of Butterfly-Inspired Intelligent Adaptive Façade, which is conducted by a collaboration of Ali Najafi. This article focuses on the evidence-based design technique of smart facade which respond to both environmental parameters and occupant needs. So, an origami-based envelope inspired by the morphology of butterfly wings is studied to provide visual comfort and reduce the energy consumption of an office room in Hamadan city in Iran, which has a cold and dry climate. The main goal is to find the optimal movement pattern of this smart facade to achieve the trade-off between the research objectives. Besides, a new indicator has been proposed to measure the luminance uniformity distribution of the office room spatially. Studying the butterfly wings movement in a Nature scientific report paper inspired the authors to model a dynamic facade. They inspired triangular module modeled parametrically with 10 different modes. The first mode acts as a full vertical shading, which blocks most of the sunlight penetration. The higher the number of modes, the greater the opening of the facade, and shading gradually becomes a horizontal one. So, this adaptive modular smart facade could change its shape to adapt to the environmental and also occupant needs. Following modeling in rhinoceros and grasshopper, daylighting and energy simulation was conducted via Ladybug tools. The base model, which is a simple model without the proposed dynamic facade, and also 10 models with static facade, studied hourly in 4 days. So for each mode, 52 hourly values for daylighting and also the same for energy consumption were extracted by Colibri, comparing the weighted result of each mode, making it possible to find the optimal mode for each hour. To study daylighting in this research, the illuminance uniformity distribution, which is presented in the European standard for lighting in an indoor workplace, was chosen. In this method, first, the illuminance received by the sensors on the table surface should be evaluated. Then the average illuminance should be calculated. If the sensor point with the lowest illuminance received at least 40% of the average, this table surface meet the standard needs. To extend this method, the authors proposed a spatial illuminance uniformity distribution SIUD, which evaluates the uniformity for the entire room. In this slide, you can see received illuminance for different modes in June 21 at 12 p.m. In this slide, the energy consumption of the base model is compared with the most optimal model. The hourly mode number is presented on the orange line, which is the result of the optimal model. Results show that except March 20, in other days, the research proposed model could save averagely about 38%. The illuminance analysis comparison results of the two models indicate about 8% improvement in daylight scattering. Considering just daylight uniformity distribution shows that it could be improved by more than 30% in other mode configuration. Thank you for your time and consideration.